Good morning or good afternoon, depending on where you are. Welcome to Pulsar Summit Asia. And this is Shivji. He is a senior software development at nutanix and work for the Beam team, helping nutanix customers to minimize cloud cost and security risk for hybrid cloud usage. And this afternoon, I will introduce structured data stream with Pulsar. And welcome, Shivji.
Thanks, Jennifer. I hope my slides are visible and I'm audible.
It works well. You can just begin.
Great. So, hello everybody. This is Shivji Kumar Jha. I am a senior software developer at nutanix, and I'll be talking on structured data stream with Pulsar today. So, I love spending time with data stores, data streams, data analytics, and open source software in general. I sort of started out with MySQL and spent 3 great years building MySQL replication, and I am an active contributor in Pulsar these days. So work-wise, I sort of am responsible for most of the things in the Pulsar deployment at nutanix. There are my LinkedIn and Twitter sort of accounts if you need to get in touch with me. I am also available on Slack later to take questions. Let's get started with the actual presentation now. In this presentation, we will look at little bit of background of Apache Pulsar very quickly. Then we will have some background on schema. Why should you use a schema? Why not use a schema? In which scenario you should use schema? Where not to use schema? Which schema format to use? And we will look at all those questions. Then I'll introduce what Pulsar supports in terms of schema representation, and then I'll share my learnings from using Pulsar schema for over a year in production. Lastly, we will finish with the Q&A session. So do type in your questions, and I'll get back to those at the end of the presentation. Regarding Apache Pulsar, it's a cloud native software. It's from day one. It's been written for cloud, and it's a distributed messaging and streaming platform. In short, it's a pub sub. So like you see in this diagram here, you can produce data, and one or multiple consumers typically can consume the data that is being published on something that is a shared notion called topic. So the producer will produce on topic, and the consumers will have their own offsets and consume from that topic. A very quick highlight on what's amazing about Pulsar that works for us. It has a modular design for coordination among its nodes. It uses Zookeeper. So you set up a Zookeeper cluster for your Pulsar deployment. You use Apache Bookkeeper for storage when you work with Pulsar, and then you have the broker nodes, which are basically the heart of Apache Pulsar ecosystem. And all of these are separately deployable modules. You can horizontally scale all three of these components. Pulsar gives you an extremely low latency with durability using Bookkeeper. Latencies for us typically are 2-digit milliseconds. It supports multi-tenancy, so you don't not only have this notion of topics where producer produce and consumers consume. You can group topics, and the group is called namespace in the Pulsar lingo. On the namespace level or on the topic level, both you can define your settings. That's pretty helpful. There's another tenant on top of a group of namespaces called uh, tenant, and then it also supports geo replication, so you can have multiple clusters of Apache Pulsar, all replicating from each other in real time. and this deployment will help you achieve availability when you have a disastrous situation. Uh, Moving on to a little bit of background on what and why of schema. So a very basic understanding of schema is being presented in this slide. Let's say you have employee object representing employee record. We have John, his employee ID is 7, and there could be other attributes to this employee record. So you basically, when you want to send this data over a network or write to a file or something, then you basically encode this record and represent it as a form of stream of bytes. Formally, this is apart from encoding called serialization. This is a term that we will come back to later in the presentation. So we will either call it encoding or we'll call it serialization more formally. On the other end of the network, or if you write to a file, when reading back from the file, you want to have a way to get back your employee record that you initially encoded via a decoder. And this act of decoding is formally called deserialization. This is again a term that we will come back to later. But what I want to express from these two slides is that when you want to transfer data over network, you typically take your domain objects, you grab their instances with data, you encode them to a stream of bytes, and then you sort of either store them or transfer them over the network, and then on the other end you decode it and get back your original data. So there are a lot of different ways in which you can do your encoding or serialization. For instance, if you're using Java, you could use the default Java serialization module to encode your instance to a stream of bytes. With Python, you can use the pickle package. With Ruby, it's Marshall. But basically, all in all, there is a way in pretty much every programming language to serialize its native objects into a stream of bytes. The problem with using serialization that comes with a programming language is that you sort of get logged with that programming language. In today's age, you want your team to be able to use whatever languages that is good for that use case, plus what your developers find most productive for them. To get out of that, you can probably think on the lines of web APIs. Web APIs, you generally use JSON or you use XML to represent APIs, and beyond the APIs in the separate microservices or your applications, they will have their own understanding of how to decode or encode the object into JSON or XML. Personally, the problem I find with JSON is it's too verbose. What that comes from is the fact that every data object representation, when it is expressed in JSON, will have keys and values. Because you're sending keys with every single data object, you sort of have a lot of data that is extra from the data that is being transferred. The other problem with JSON I find is that you can't express types when you serialize in JSON. You when decoding it, you try to looking at the data, guess types, and that is a real problem. You need to be able to express data type in a more better way. So what you actually need is a way to save space when you send data over network, and then if you make a set of rules and you document it well, and you say, well, this is what we will follow across languages, across application, and all of that, then there is other problem where then suddenly there is a use case where somebody comes and tells you, hey, I want to add a new data type, and then you have to think of how to maintain the previous uh, way of encoding and decoding things, how to maintain the new way, given that there is a new data type again. So all of these are problems that are typically in already understood in the schema space. And then you have vendors like Avro and Protobuf and Thrift, which are there to solve exactly these problems. We'll look at the Avro as an example in little going ahead in some slides. So like I said, the schema is defined and documented. It's great. Someone wants to quickly add a new data type. How does the decoder know it among all schemas? How do you know that a pair of those are same domain objects, just that a new field was added or a field was deleted? So these are basically versions of the same domain object schema. um, you do that by schema versioning. So when you update the schema for a given domain object, let's say you have an employee and you have employee ID, you want to add employee name or department, then they go on different versions. Version 1 will just have ID, let's say. Version 2 will have ID and name. Version 3 will have ID, name, and department. And with versioning, you can actually have producer on a different version, consumer on the different version. So the upgrade path for your applications that are producing and the applications that are consuming can be separated. So like I promised, we will look at how you can do your serialization and deserialization with Avro. Here is one way to do it. There could be a slightly different version of it as well that could also work. But in this fashion, we will first encode data with a schema that will represent in a DSL that Avro defines. You can either ship that schema to your consumers. So when you encode using that schema, your consumers can take that schema and decode it using that schema to get back the original data. Or if you want to make it more scalable design, you can let's say make a service where you will keep all your schemas, and the thing that moves around between producers and consumers is actually schema ID. We will again look at a little bit of more in schema ID and schema definition representation. But for now, it's enough to know that we can have a central place where you have a service where you present schema ID, and with the schema ID you get back your schema. So the producer could upload the schema and the consumer could sort of download the schema given the schema ID. How you can the one way to pass on the schema ID from producer to all the consumers is that you could ship schema ID with the message itself. So the first few bytes of the message could always be schema ID, and beyond that uh, you have the message. With the schema ID, you go to your schema store and get the schema. With that schema and the data beyond this bytes for schema ID can be decoded using the schema. You can have sort of a fixed understanding that I'll take a long always for a schema ID or something like that. That will help you make a format of the message and a schema ID in the beginning. Um, so now let's look at why you should use schema, and in certain cases if you should not use schema, how do you make that decision, and what are those use cases where that is a good idea. So like we discussed earlier, a producer is a separate application, consumer is a separate application, and then you have Apache Pulsar. The producer application actually produces bytes. Apache Pulsar actually stores it in a durable and distributed format. And consumers, there could be multiple consumers, they can connect to Apache Pulsar and get those bytes. This is a very simple way to use Pulsar, and these bytes can actually be encoded here and decoded here using schemas that are maintained in this application and this application. So the data is stored in binary, but Pulsar also supports several schema types like Avro, JSON, protobuf, and all of it for encoding data on the producer application and decoding data on the consumer application. So should you use a schema? Like when should you use a schema? In my opinion, there you should try and use schema as far as possible, but there could be use cases where you get some advantages from not using a schema. But the one thing that you have to always be aware of is that in any data store, if your schema is not explicit, it's probably implicit, spread across somewhere in your code. This is a tweet that I came across some time ago, and I sort of really resonate with the feelings here. So the author of the tweet actually goes on to say that I am starting to think that schema less, which is quite a buzzword these days for last 4 to 5 years, it just means your schema is scattered randomly throughout your code or throughout your applications, microservices, whatever. It is almost impossible to troubleshoot anything non-trivial because there are endless assumptions but few explicit requirements. So in effect, it's always better that you have your assumptions written down, your requirements are written down well in a well understood format, and that means that you use a schema explicitly and not go schema less, which is uh, the implicit schema representation. So here are some cases where you would want to go schemaless or not present the schema very explicitly and keep it flexible. Case number one is if you have really non-uniform data, if you're getting data from a different third-party system and you as an application are just sort of doing certain things there and maybe distributed it to other applications which actually go and understand that data. That's one reason. Any non-uniform data, let's say you have an application where there is a one field where you want to uh, send a blob of custom fields that the UI can use to display information in a certain way. You want to be flexible there. If you have a case where you have one field in your schema where um, that it's typically an enum which indicates how the data further can be decoded. um, so typically you have enum, you get one of those values in that field, and based on that field you have a factory which helps you understand how to decode the remaining data. That is one use case. Schema migration is another use case where if you are not storing schema explicitly in a database or a service, it's easier to migrate data because there is no schema explicitly stored somewhere. You don't have to do a migration at all, but then you have to think of this with some caution because there is schema actually, if not explicit, implicit, and still needs to be taken care of. There's a really nice blog about this by Martin Fowler, and this is a reference that I've used to get this image. If you want to sort of read more about this, you can follow this link. So we will now look at the different schema formats and supports that Pulsar comes up with. We'll start with a really simple one. Let's say you have a domain object which is a user, and we care about the name and age of the user. You can use your programming language. In this example, we are using Java. You take a producer object, you tell the producer that you only want to use bytes. You don't really care about the schema. You only want to transfer the bytes from producer side to Pulsar and from Pulsar to the consumer. You take your object and then using the um, default serialization for Java, for instance, Java serialization, Python Speckle or something, you serialize the user instance into bytes, and then you send over bytes using the producer. Um, you can go a step ahead. Instead of bytes, you can say that, well, I want my messages to be more readable when I consume, and not get into all the bytes, which could be a little bit difficult for debugging. You could use string schema. So when you make a producer instance, uh, you say that I want to use string schema. You make a producer with schema.string, and then create that producer instance. When you send a new message using that producer, you just put a value here, and then you send. On the consumer side, again, you state explicitly that the schema is actually a string schema, and you can receive this. The returned value will actually be a string, and this string could again be a JSON. It could be anything that you want. So it's not only a string, but a host of different primitive types that Pulsar schema supports. You can have int, you can have float, double, byte, string. These are actually, like you would have guessed, similar to the primitive data types of different programming languages. Like Boolean of Pulsar schema, Boolean schema is similar to the Boolean data type in Java. Int 8 is like byte, int 16 is like short, and the same. um, so going beyond primitive schemas, we will now look at something that Pulsar calls struct schema. Struct schema is basically structure, um, and it sort of is represented either using JSON schema or Avro schema or Protobuf schema. These are the three formats that Pulsar supports. So again, let's take the same domain object, user, and when we make the producer instance this time, we say that we want to make a producer, and the producer should store in its in the application itself, in the producing application itself, the user dot class schema. To Pulsar, you just say I want to use JSON schema of user dot class, in effect a JSON schema that represents something like this, and bind it to this topic. So next you make a user object, and you just send it using the producer. Under the hood, what the Pulsar library, the client library, which has this producer code, what it does is it looks at this class, it makes a JSON schema out of it, and when you send this object, it takes that schema to encode it and then send it to Pulsar. So you don't really care about how to encode it. We will look at Avro as another example. For Avro, you will do the similar thing. When you make a producer of Pulsar, you say that I want to make a Avro schema of this user class, and I want to create a producer like that. And when I want to send a value on this producer, I can say that I want to send a new message, and the value should be build a user object, user.builder, give name, give age, and then build it, and then just send it. So again, like we talked in the previous example, under the hood, what producer of Pulsar will do is it will take this object, it will serialize it using the Avro schema that was constructed here, and then send those Avro encoded bytes over to the Pulsar application. On the consumer side, again, you say that you could say that I want to use Avro, because you used Avro to produce, and like you said in the producer, you will say that I want to use this schema. This schema again will be stored in the consumer application itself, and when you consume this um, consume on this consumer, you actually get a user object, which you initially actually sent here. The thing that I have been stressing with both these examples of JSON schema and Avro schema is that if you write your code in this fashion, what you're actually doing is that your application, which sort of is using the producer or consumer library, that application actually knows that for this topic I'm using this schema, and in this particular example it's actually hard coded. So like we discussed, the schema is stored in producer and consumer objects, and this is called client-side schema storage approach. Now there are a few problems with this. So your client is not only responsible for serializing and deserializing data, but the client is also keeping schema with itself and keeping a mapping of which topic should use which schema and all of it. This is sort of something um, that is still fine, but if you also have a lot of different versions of the user object, we talked about the user object. If you um, uh, instead of name and add age, add uh, let's say nationality, right? Then you have a different version. So the consumer now also has to know that for the user, I could either have to decode it using that user class which contains only name and age, or that class of user which contains name, age, and the third field that we added. So all of this is actually a lot of responsibility that we are encoding in the client application itself. The other solution to do this is that thing that we discussed with the Avro example earlier. You with the Pulsar, you actually get a server that we actually talked about in theory earlier. So that server is called schema registry. Schema registry is basically, if you look at it in a simple fashion, service that allows you to upload schema and returns an ID. You can just keep that ID and fetch that schema back from that central schema registry service. So when you are actually producing data into Pulsar, you upload the schema to the central server, which is schema registry, and you add the schema ID to the message in the beginning. When consumer, you get those bytes, and then you know that the first X number of bytes are containing schema ID, and that has to convert to long data type. So you fetch that, you make it, you cast it into a long value, get schema ID. You fetch that, you fetch the schema corresponding to that schema ID from schema registry, and using that schema, you can actually now decode the message that you had initially sent on Pulsar. And the schema registry not only allows you to store and fetch it, you are also getting this additional feature of versioning of schema with the Pulsar's schema registry, which comes free of cost, shipped with the Pulsar application. If you go a little bit more deeper and look at how schema registry actually stores that information under the hood, so the entity for this web service called schema registry is something called schema info. It looks like this. You have the name of the schema, you have the type of the schema. This type of the schema could be string, it could be byte, it could be Avro, it could be JSON. And for a string, this is empty because it's a string. You just sort of decode it using the default understanding that the compiler has. For Avro, you could have some data here, and you write Avro here. If it is Avro, then this data will be used to exactly make that Avro schema out of the bytes here. And properties is anything that you would sort of keep here for your applications to sort of send information from the producer side regarding how the schema is to be understood. Are there edge cases and things like that? So the way schema info works with the whole evolution of schemas is that every schema info is actually tied with a version, and it's stored when stored against a topic. It has a version of the schema, and then the schema info against it. Schema version actually manages the changes happening in the schema within a topic, and messages produced with a schema info is tagged with the version of the schema. So user schema version 1, user schema version 2, user schema version 3. These are all actually different versions on the same domain object user, and the producer could have encoded with any of them, and that will be known from the message itself because it knows the version. Like we discussed earlier, consumer can use schema version to fetch schema info and decode the message with schema info. If you look at it, to understand what this field will contain, this is actually schema type. This is a sort of soft delete feature, time at which this schema was created, the user which published this schema, the actual data that is the schema, and hash map of string and string, which allows you to put some random keys and values for your application to understand. For the whole schema registry, you have REST APIs. You also have CLI commands, which you can use to do your admin tasks on the schema registry. So you can get the schema, you can update the schema, which will result in a new version of the same schema. You can delete the schema, or you can get the schema at a given version. So user schema, but version number 2 is what I want, that you will get with this API if you want to do your admin task or debug. Moving on to the last section, which is about the learnings that we have had using the schema feature in Pulsar. For over an year in production, we have been using schema from a really early time, and we have also been a contributor in this side of Pulsar. So struct schemas actually really model your domain objects well. Struct schemas in Pulsar are JSON, Avro, and protobuf. Byte schema is something I would generally avoid, but we discuss some cases where you have non-uniform data or something, then you would want to use byte schema. Avro schemas we have been using for some time, and we prefer Avro because we find JSON schema too verbose, with keys and values both going on for every message that we send. Proto is obviously awesome. We really want to move to Proto. When I say Proto, it's protobuf. But I think it's still being adopted with the sources and sinks that Pulsar sort of integrates with. You can have different sources from which you publish data to Pulsar, or you can have different sinks which sort of get data from Pulsar. And with those source and sync systems, I think Avro is something that's more widely accepted than the protobuf schemas. Avro, because it doesn't ship the whole schema, but just the schema ID with every message, it helps you save data per message against JSON schema. And like we discussed, Avro is very well adopted among the sources and sinks the Pulsar IO supports. In general, I sort of omitted this whole topic for the timing issue. But this is, and again, an important topic when you design your usage of Pulsar in between your producers and consumers, and you sort of look at schemas in your producer and consumer application. You should also look at how the evolution of schema on the Pulsar end will look like. You have different facilities that come with different compatibility type. If you want in future, if you only want to allow deleting fields and adding fields which are optional, then you could use backward transitive is similar to backward, but then you don't only match the compatibility with previous version of the schema, but all the previous versions of the schema. We use forward compatibility type most of the times, which allows us to add fields in future, and it allows us to delete fields which were marked optional earlier. At times, we also use a schema compatibility mode, which is called none. Basically, what that means is that your compatibility is not really being checked when you upload a schema. There are more subtle things there, which is actually documented. but I'll omit those for now in the interest of time. But the idea here is that you should always consider using compatibility that you set on the namespace for your use case, and decide on the compatibility before you actually start implementing the whole thing and start sending messages and consuming messages, etc. um, the other idea that we have learned over time is that what if you have a domain and you have a lot of objects, or in the domain you have multiple microservices, and within one microservice you have multiple domain objects, then you could it's not like for user object you should write it on one topic and the account should write in another topic all the time. For us, what dictates what data goes on which topic is actually that um, wherever we want ordering among certain things, they have to go on the same topic, on same partition. So we like to sort of in short advertise it internally in our place as one domain, one topic. It could have users, accounts, or different domain objects, but they all go on the same topic. And from the sort of message, we take the schema ID and decode using that, as opposed to keeping the schema with the producer or consumer application. The other thing that we use with this scenario is auto consume, so the consumer doesn't stick to one schema for decoding every message. It sort of gives you a list of fields on of Java's reflection kind, um, and then looking at those, you can sort of get back your original instance of the class that you used to make that message. Schema auto update strategy, in these cases we use none. I have placed a link to documentation where these things are explained really well. The schema documentation these days is really amazing. The schema management process that actually works for us is that we keep a GitHub repo with schemas. We use code reviews to review schema changes. So whenever there's a evolution in a already known schema, or a new schema is published, that goes through a code review process that we use for reviewing any code. Schemas also get reviewed there. We have for Java, for example, we have been using a Maven plugin that generates Java POJOs, the plain old objects of Java with only the attributes and no functionality. The simple POJOs are generated using Maven plugin, which given the Avro schema in AVSC format, gives me the Java object. And then we use this collection of Java objects embedded in a library as a dependency to our microservices, so that the domain objects, the POJOs in Java corresponding to those Avro schemas, are by default added to the microservice that is either a producer or a consumer. References, like I said, Pulsar doc for schemas is really amazing. You could get started here. There are 3-4 more pages with a lot of examples that are there, and it's explained really well. With regarding auto update strategy, you could look at this link, which is Pulsar admin CLI commands. Um, Schema evolution in Avro, Thrift, Protobuf, all of this, it's been really well explained in this blog. This is sort of a reference, an amazing blog from Martin Kleppmann that we have been sort of referring and using in our designs. Topic design, again, Martin Kleppmann has published a really good blog, and it's been added to the conference blog as well. Schema compatibility design, you could actually the table that I showed earlier, you could actually find it here. You can read more about this compatibility modes here. This is conference blogs, but you also have these in Pulsar docs as well. And that's it from me. This is some ways in which you could stay connected. You can contact me on Twitter or LinkedIn, or I am available on Pulsar Slack all the time. You could drop me hello there. And then there are the Pulsar mailing lists.
Thank you,
Um,
Shiva.
yeah,
Actually, there are a lot of questions. The first
sure.
one is okay. How is the learning curve of the schema language like Avro? Is it easy to learn? Does it solve all the Pulsar use cases?
The learning curve is not very steep, I would say. It does take some time to grok all the ideas about Avro and how Pulsar uses Avro and the schema registry in general. But we've been using it for a long time now. We understand it well, I think, and we've been contributing as well. There is a lot of good things that is being done on the schema side in Pulsar as well, and that's being done on all the different clients of Pulsar. Um, Schema registry in general is pretty stable and going well. You can read about Avro in the Avro documentation. You can also read about how to use it in the Pulsar test cases or examples that Stream Native puts on its GitHub account. Or if you have more questions using it, then you can always get back to the Pulsar Slack channel, where there are some amazing folks responding to every message that is out there. You can also contact me on the Pulsar Slack channel. I'm available there.
Okay,
Yeah.
thank you. Another one is, it seems that Pulsar currently supports one multi-version schema per topic. Would it be
Mhm.
useful to have a model where the schema could be defined at message level, such that a message property would define which schema the message use? Is something like this planned in Pulsar, or is it already possible?
So we use a model where one topic can contain multiple objects. Like let's say there's a web service which has users and accounts, and both these objects are being published on the same topic. We have a way to sort of put them on the same topic, and we have some sort of a wrapper client on top of the Pulsar native client, which helps us decode those messages, even though they are different schemas on the same topic. For a more formal support on the Pulsar side, which is out of the box and doesn't need extending the Pulsar client, I have a pip, which is a sort of Pulsar functionality representation. I have a work that is going on. I have a proposal for it already, that's documented. I'll send it on the dev and user mailing list in some time. I'm also working on the code to contribute that feature to Pulsar. So it should be there without those hacks. If you need it more immediately, then you can again contact me on the Pulsar Slack, and I can sort of share more details about how we sort of use a wrapper client on top of the native Pulsar client to get those things done. And we can get those done in Java and Python right now. We are also working on the Go client to get that done using the Pulsar's Go client. But it is possible with a little bit of effort. And for the out of box support, I'm working on a feature where um, if when contributor included with Pulsar, it will be rather easy to support that.
Okay, another question. How well does Pulsar schema integrate with the Pulsar function and other data systems like Flink through Pulsar connectors?
So I have not used functions a lot. With Presto, it integrates well, I think. With We do use Flink, but we use byte schema on topics which use Flink. I am not very sure if all the connectors are supporting Pulsar schemas right now. But if you are using a connector and it doesn't support it, it should be possible to extend that connector, and I think that is a good requirement that you can file an issue for in the Pulsar's issues, and that can be done rather easily, I would think. But whether it is supported in all the connectors, I think no. For individual connectors, it is supported with some to some degree, and it is not supported at all with some connectors. You can file a GitHub issue, I think, to get details about specific connector.
Okay. The next question is, compared with other big data systems that support schema, what are the advantages and disadvantages of Pulsar schema? And do you have any suggestion on Pulsar schema?
I mean, comparing, we could compare Pulsar schema with a lot of different systems. But it will be more useful to compare it probably with Kafka, Kinesis, or some similar system. The advantage with Pulsar schema registry is that it supports a lot of different types like Avro and protobuf and JSON schema. Then there are primitive schemas. Then there is a way to add schemas for keys as well as values if you have that model of Pulsar usage on your topics. And it's something that's worked pretty well for us. The connector side, like we discussed in the previous question, is a little bit of work that's remaining, but we have people who are working on schemas all the time, and usable. We are using it actively.
Hello.
Yeah, Jennifer.
Okay.
Yeah.
Okay. The next question is, what's your skill? What's the skill of your business at nutanix, and how many topics and messages do you deal with every day at nutanix?
It's difficult to come with a number, but for a guess, I think we have around 500 topics. Messages, actually, the workload on the message side varies quite a lot for us. We have a lot of stream workloads. We also have some batch workloads where you get periodic batches. But I'm not really sure about the numbers in general. So for when we have batches running, we could have hundreds of messages per second. We have when we have only streams running and not batches, we can have around 40 to 50 messages per second. But I'm sure there is bigger deployments of Pulsar in other places as well. Our usage is a little bit different. We rely a lot on schemas and asynchronous communication, and then we are trying to Pesto as. But as far as Pulsar's design goes, you can actually store millions of topics in Pulsar. There's also support in the latest versions for moving the topics system topic data to topic instead of zookeeper. So that should help there as well in adding those many topics, with like millions of topics in one deployment. And our deployment is, I think, a little simpler with only one Pulsar cluster. We don't have geo-replicated clusters right now. We are looking at those. But those are our numbers. But there are bigger deployments. And Pulsar officially says that you can support millions of topics.
Okay, great. Thank you. There are still some questions on the waiting list. I think I'd better encourage them to ask those questions in Pulsar Slack and connect with you. They can connect with you directly. Okay, so thank you very much for sharing your great talk here, and thank you everybody for joining us today. Now I'd like to announce that the two-day event Pulsar Summit Asia ends successfully, and thank you again. Thank you everybody again for your time and efforts you put in this event. All sessions for this summit are recorded and will be shared on YouTube, Bilibili, Tencent Video, and other platforms. You can follow Apache Pulsar on Twitter, LinkedIn, WeChat, and other social media, and then you will be notified with those updates. Meanwhile, if you want to learn more about Pulsar Summit and Pulsar updates, you can join our Pulsar Slack channel and the WeChat channel. and you will get those updates the first time when we announce it. And thank you, everybody. Thank you for your time. Bye. See you. See you in another platforms.